Permutations. Permutations are the way to determine the arrangement of a list. How many different ways can we arrange the elements of a list? And usually it's with some sort of like order that matters. An ordered arrangement of items without repetition is a permutation. So that's why we've been talking about rearranging A, B, C, D 3 different ways. That's a permutation. In questions 1 through 4 of the Getting Started, the different 3-letter strings formed from the first 4 letters of the alphabet are permutations. An arrangement that's ordered where the items are not allowed to repeat. There are different notations that can be used for a permutation of R elements taken at a time from N elements. Here are 1, 2, and 3 different ways we can arrange permutations. This is the one that's most common for us because it looks like a calculator function that we're going to be practicing too. This is another way where it's got kind of this probability style, but we're really looking at how there's a number comma number. This is the total, and this is the number of things that we're going to arrange those items into. Or we could even put P with N over R, not as a fraction, but just as like a superscript subscript. Yeah, I'm looking at my camera screen going like, oh, that's the right letter. So suppose you form 2-letter strings from the first 4 letters of the alphabet without repetition. How many choices are there for the first letter? 4, right? A, B, C, D. You can choose any of them. It's your choice, your call. But the idea is without repetition, once you pick that, you're not allowed to go back to it. So your second choice only has 3 choices available. But because of the counting principle, that rule for determining how many events, total outcomes there are that are possible, the counting principle says just multiply 4 times 3, and then that lets us be able to rewrite the answers. There are 12 different ways to arrange A, B, C, D into 2-letter permutations. I got to be careful with my words. I really need to say permutation as often as I can instead of any other arrangement. So 1B continues. How many different permutations are there of 2 letters from the first 4 letters of the alphabet? And when we write this, I'm writing it like this. 4 letters permuted 2 ways. 4 things in a permutation of 2. It's the same calculation. There are 4 times 3, which means 12, right? Because we're multiplying them. Now, if we write that 4 and that 2 into our notation from up above, here's the way that we write it. We write it as 4 factorial, I'm writing it right now, 4 factorial over 2 factorial. So 4 permute 2, or the permutation of 4 things in 2 ways, or permute 4 over 2. It's almost like it's telling us what should go in our factorial here. Keep that in mind. Let's go to the next one. Suppose you form 3-letter strings from any of the 5 letters in the alphabet. Oh, I should add this up here, by the way. This would be 4 times 3 times 2 times 1 over 2 times 1. The 1's cancel, the 2's cancel. It is indeed 4 times 3, which makes 12. Okay, back on track. Suppose you form 3-letter strings from any 5 letters of the alphabet. Write the number of permutations as a ratio of factorials. So if we have 5 things permuted 3 ways, or the permutation of 5 things in 3 ways, or the permutation of 5 over 3, then the top number of our ratio is always going to be, I don't want to build that. I want to build up to it. Let me build up for a second. Let me pause, time out, put a pin in it. Let's work backwards. Wasn't it 5 times 4 times 3? That's 5 letters permuted 3 ways. There are 3 entry spaces. There's 5 options for the first entry, 4 for the second, 3 for the third. So if we were to continue this, 5 times 4 times 3, we would go times 2 times 1. So I'm going to add the rest of the factorial to the fraction. And if I put 2 and 1 on the top, I have to put 2, and 1 on the bottom so that things stay like balanced. Like I wouldn't want to change this to a totally brand new number. I still mean 5 times 4 times 3. So to write it in factorial terms, the 2 and 1 would reduce, but then all of this can be rewritten as 5 factorial over 2 factorial. So do you see how that's not a 3? That goes right here. It's 5 minus 3. 5 minus 3 goes right here. How many 4-letter strings can you form from the first 10 letters of the alphabet? Write the number of permutations as a ratio of factorials. By the way, it would be 10 times 9 times 8 times 7. I'm going to finish the video in the next one. I'll see you guys in the next video. Bye!